So a student asked me a question. I need help simplifying radical expressions. I just don't get radical expressions. So I'm going to show you 5 different expressions and show you how to simplify them. But first, if we're just meeting, my name is Mark Nolde. I've been teaching high school math students for over 20 years. That includes my 4 daughters. So without further ado, let's get into it.
So simplifying radicals. So what you're looking at here is the square root of 8. And when we say to simplify, what we mean to do is extract as many perfect square roots as we can, or the largest square root that we can. One way, or one thing that is wrong, students who weren't paying attention in class maybe type this into their calculator and they go, oh, 2.828, I think it is. This is not a simplification of this. It's pretty close. It's a decimal approximation to the nearest thousandth, but this is not equal to this. Square root of 8 is approximate to this. So when we say to simplify, what we're talking about is extracting roots. And this is what we mean. Square root of 8 is equal to the square root of 4 times the square root of 2. Okay, we know this from our exponent rules. And the reason we use 4 and 2 is because 4 here happens to be a perfect square. So when I say simplify the square root of 8, this is what we're looking for. We simplified it because we got the square root of 4 out of it, and it's just a 2. So this has the simplification of 2 root 2. Okay, not all of them will simplify. Let me switch color here. Suppose I have the square root of 10. A lot of times a student will think, well, that's an even number. It must simplify, right? But no, it doesn't, because the only factors of 10 happen to be 2 and 5, right? So 2 and 5 are 1 and 10, but square root of 1 is 1. So the square root of 2 times the square root of 5, even though this is equal to this is not a simplification. This hasn't made it any simpler. In fact, it's made it a little more complicated. I don't do this because 2 is not a perfect square, and 5 is not a perfect square. So sometimes when you see a number like this, that's it, square root of 10. It doesn't get any simpler than that. All right, let me show you another example. All right, 32, that's a little bit bigger number than 8. So the square root of 32, let's see. What is a perfect square factor of 32? Don't know why I switched to pink there. The biggest factor, the biggest perfect square factor of 32 is 16 here. So we take that and we say the square root of 16 is 4 times the square root of 2. So square root of 32, when simplified, equals this. And if you type both of these into the calculator, you'll get the same decimal approximation. One thing sometimes when we're first learning these that students will do is they'll say, hey, I know 4 goes into 32, and 4 is a perfect square. So the square root of 4 times the square root of 8 equals the square root of 32. Yep, sure enough. So I'd say 2 root 8. But we learned on the previous screen that the square root of 8 is really the square root of 4 times the square root of 2. And the square root of 4 right here happens to be 2. So when I multiply 2 times 2, I get 4 root 2. So it's the same answer as over here. So it's not wrong to do it this way, but if you notice, it takes more steps, all right? So if you can learn to recognize the greatest square root in the radicand, then you're just going to get through the problem a little bit faster. All right, can it get any more difficult? Let's see. All right, you're going to see these when you learn to simplify radicals. So I have 32, which I already know from the last slide, is 16 times 2. And I know 8 is 4 times 2. So I've gotten my largest squares out that I can get. So this becomes 4 root 2, same as the previous slide. And this becomes 2 root 2, same as the first slide. And what you'll notice here is root 2 and root 2. Now, what you'll learn is that we're using distributive property here, which means you're technically undistributing, right, which isn't a real word. You're factoring the square root of 2 out of this expression over here. And then we can add what's in the parentheses, and we ended up getting a 6. And we usually write the square root of 2 after the 6. But a lot of times I just say to students, hey, what if you had 4x plus 2x? So I have the same terms here. These are both x terms. Well, think of these as both being square root terms. So it's a little bit faster sometimes to think of it that way, because just like over here, I'd say, all right, that becomes 6x. Over here, this is going to become 6 root 2. And it saves a step from over here. So that's just another little shortcut for you to think about when you're doing these. All right, so we're not always going to be adding. Sometimes we will be subtracting. So 75, let's see, what is the largest perfect square that goes into 75? I think it's 25. And 25 times 3 is equal to 75, so that works. And then we're going to subtract. Let's see, the largest is 16. That's a tricky one if you don't know your times tables. But 16 times 3 is 48, so root 16 times root 3 is root 48. So again, here I have like terms, quote unquote, or air quotes, and like terms. So let's simplify the 25. Square root of 25 is 5. Square root of 16 is 4. And when I go to subtract these, 5 minus 4 is 1. So in the beginning, a lot of times when we're doing things like this, say 5x minus 4x, I'll teach students, if it helps you remember that there's still an x there, go ahead and put the 1x. But this, just like this, those are understood, right? These are understood. So you can leave it there if you want. It's not wrong. But if you're checking like an answer key or the back of the book, it's probably just going to say the square root of 3. All right. Ready for the last one? Let's go. Oh, look at this. So sometimes, here we go. I know that 25 is the biggest square factor of 50. And over here, let's see, 9, right? 9 times 3. So plus gets a plus. Square root of 9 times the square root of 3. So simplify. 5 root 2. And let's see, square root of 9 is 3. So when we get the square roots, notice what's left over. Are they the same? No, they are not. So those cannot be combined. That would be, think of if I had 5x plus 3y. Could I add these two terms together? And no, of course I can, because they're not like terms. This is an x term and that's a y term. So for the same reason, we cannot simplify any more over here. The square root of 2 and the square root of 3, there's nothing else that I can factor out or undistribute out, if you want to call it that. So this is as far as we can go. And the way to check these, incidentally, is just like we did on the very first slide. Type this into your calculator and then type this into your calculator. you will get the exact same decimal approximation depending on the calculator you're using. If you're using one of your, we use in our school the yellow box of magic, I call it. So you'll get 8 or 9 decimal places. They'll all be the same if you've done the work right. This will have the same approximation as this. And that's how you know that's a good indication that you've gotten it done right. There are some calculators that will simplify this. I'm not certain offhand which one. I think a Casio 36 or something does. But the calculators most places use won't do that. Those are the TI-84s. Okay, hope that's been helpful for you. Go ahead and smash the like button if you don't mind. It helps the YouTube algorithm. And I will see you the next time.
Thank you for watching till the end. And remember, pay attention, do the work, and ask questions, and just never give up. So if you've gotten value out of this video, please help me out and hit the like button for the YouTube algorithm. And remember, math is not a spectator sport.